So what we're going to do in this unit is it's really a continuation of the last unit, but we're going to move on to 3D geometry and look more about volumes. We're still going to have to deal with the surface area and uh, the surface areas of those 3D objects. We're also going to include the volume. So in basic words, what does volume mean? Okay, you really should come up with your own definitions for this. But some ways we can think of volume is space that it takes up. Okay, so space that an object takes up. Okay, we can think of how much it takes to fill up a 3D space. Okay, or we can even just say 3D space. Okay, what I would like you guys to think of volume is in general, mathematically, we think of volume as area that has thickness. Okay, so area with thickness is how we generate volume. Okay, and to the shape that we use to measure volume, we use cubes, because cubes are essentially when we take area, a square area, and give that square area some thickness, because we measure area with squares, so we're going to use cubes to measure volume. So we use cubes to measure volume. Okay, so when we go from 2 dimensions area to 3 dimensions volume, we were just adding in height or depth. Okay, and for that matter, we can actually go backwards and say, well, when we think about the 0 dimension, we have a dot. 1 dimension is a line. 2 dimensions, we just extend those lines, okay, in 90 degrees, and we get area. And if we want to go to 3 dimensions, we extend those points in 90 degrees and we get volume. Okay, so when we go, there's a very easy transition from 0 to 1 to 2 to 3 dimensions. In fact, we can do the same thing to 4 dimensions. Okay, so to get the volume rectangular prism, we want to think of any prism as something that when we slice it, if we slice through here like a slice of bread, okay, like a loaf of bread, every cross-sectional area has the same area. Okay, it has the same shape, has the same area. So we can use the base as any face that has the same area when we slice it. We can slice it this way as well. Okay, so some people like to think of it that way, but I think of this as more like a loaf of bread. So when we take a look at this area here, we have this shaded area, and we can take the area of this space here. So this is the area of face. Okay. And we can take the height or the thickness, I'm going to call that h. We can say the thickness is h. Okay, so the volume of this prism is, we take the area of face and we multiply that by the thickness, which we'll call h, or the height in this case. So this is a formula then. We're going to use, okay, I know that a lot of you guys like to use length times width times height, which is okay, but a better formula really is to think of volume of any shape is volume is area times thickness, which we'll call just h, area times h. Okay, so then that length times width gives us a cross-sectional area, and then we multiply it by the depth of the thickness. Okay, so if we want to calculate the volume of a triangular prism, well, that's as long as any prism is a shape that when we slice it, every slice's cross-sectional area is going to have the same shape or the same area. So if I slice it in this way, we get all triangular faces. So what we can do then is we can say that this represents then the height. Okay, so in this case, the height is 4 centimeters. The base is going to be this face here, which I'll do in a different color. Okay, there's our base. And that base is equal to 2 times 5 divided by 2, or 5 centimeters squares. Okay, and the volume of that prism then is, again, we generalize volume as, the volume is going to be area, or 5 centimeters squared, times the thickness. In this case, the thickness was 4 centimeters. So our volume works out to be 20 centimeters cubed. Okay, and some of you may have just done length times width times height. Okay, that's going to give us 40, and we want to take half that volume because this shape is half the volume of the rectangular prism that would have formed. And that's perfectly fine. But again, we want to start kind of thinking of things a little bit differently. Okay, so Jake's family opens a full carton of ice cream for dessert. So this carton is a rectangular, sometimes you might find these in Safeway, a rectangular block of ice cream. And they eat part of it and they're left with 3/4. Okay, so this, let's say it's strawberry. I'm gonna do this in pink. We have pink. We'll do red. Okay, so this volume here is what's left. Okay, and the volume of ice cream did this. What volume did they eat? So basically, we can find, first of all, the volume of this whole box is going to be 18 centimeters this way, 12 centimeters this way, 9 centimeters in this direction. So we can do the product of those, 18 times 9 times 12. That gives us a whole volume. And then we can multiply this by, we only want 1/4 of that, so we can just divide by 4. So this volume works out to be, what's that going to be? 27. 12 divided by 4 is 3, times 9 is 27, times 10 is 270, and then, so it's going to be 270 plus, and we take times it by 8, 27 times 8 is going to be 200, and I think that's 16. Okay. 27 times 8, yeah, 216, I think. Okay, so we end up with 486 centimeter cubes that was eaten. Okay, you might want to double check that calculation, but by my mental math, that looks okay.